Okay, next question we will be seeing is match the following. So you can see list 1 and list 2, rainfall intensity, rainfall excess or excess rainfall, both are same thing, rainfall averaging, mass curve. Okay, so here we can see the other list, that is Isohyets, cumulative rainfall, hydrograph, direct runoff, hydrograph. So just we have to compare rainfall intensity. Rainfall intensity, that is in centimeter per hour, and it will be given in which graph? Hydrograph. Okay. Rainfall excess, that is excess rainfall, many times we are calling it as direct runoff hydrograph also. So excess we can directly relate it with direct runoff hydrograph. Then rainfall averaging. So average rainfall, that we are generally finding by isohyets. Okay, I will just explain you. And mass curve, that is one type of cumulative rainfall. Okay, mass curve is cumulative rainfall, so we can easily get the answer. Okay, so rainfall intensity is 3. Okay, rainfall excess, that is 4. Rainfall averaging 1, so answer is B. Okay, now let me explain you rainfall intensity. See, rainfall intensity we know it is expressed in centimeter per hour. Okay, and we know that is given by hydrograph. We have just seen how hydrograph looks. So on y-axis we are having rainfall intensity in centimeter per hour, and here time duration will be anything, minutes or hour or whatever, doesn't matter. Okay, same way rainfall excess, if I am talking about rainfall excess or excess rainfall, somewhere in some books it is written excess rainfall, or even direct runoff, that is excess rainfall is direct runoff. Okay, so now we know that excess rainfall formula also, just for the revision purpose I am writing down excess rainfall or direct runoff depth. Direct runoff depth. Okay, so don't get confused between excess rainfall, both are same thing, excess rainfall or rainfall excess or direct runoff depth. So that formula is 0.36 into sigma DRO into T divided by A. Okay, so here we know that T is equal to time interval of runoff data, in hours. Okay, in hours. A is your area in kilometer square or square kilometer. Then this sigma DRO, what do you mean by sigma DRO? Sigma DRO, basically sigma is summation of DRO is direct runoff ordinates. Okay, so we can get excess rainfall from this formula. Suppose x hour unit hydrograph ordinates, we are interested in x hour unit hydrograph ordinates. Then also we can find this by using the formula direct runoff ordinate divided by excess rainfall. excess rainfall. Okay, and we know that another important thing, direct runoff ordinate, direct runoff ordinate plus base flow. If we add these two things, what we will get? We will get directly storm hydrograph ordinates. Storm hydrograph ordinates. So here we can see we are able to find out excess rainfall or direct runoff depth by this formula. Just we have to take care of the units. Area will be always be in kilometer square or square kilometer. T will be in hours. Okay, and finally we can derive x hour unit hydrograph. X means any hour unit hydrograph if we are knowing direct runoff ordinates and excess rainfall. So excess rainfall we can calculate. Okay, same thing we should the question deals with another term, that is another term is isohyets. Okay, so isohyets. So isohyets are basically contours, okay, or lines. Suppose these are some of the contours or lines. I can say these are 80, 90 centimeter, 100, 110. So these are the lines joining points of equal rainfall. So that is isohyets. Okay, so suppose these are your isohyets. So here also they can ask you some questions, like they may give you some isohyets randomly. Suppose I am writing down 75, 90, 100, 125, 140, 150, 165, 180. Okay, like this I can give you the isohyets. They will give you the area between isohyets. So here basically what we are supposed to find out is the average rainfall or equivalent uniform depth. Okay, so area between isohyets, that is expressed in square kilometer. So this is, suppose these are the isohyets, so the area enclosed between this, okay, 80 and 90, 90 and 100. Okay, so area enclosed between this. So suppose this is just a random question I am solving for isohyets. Suppose they are giving the isohyets like this. Area between the isohyets, suppose between these two the area is suppose 60 kilometer square. Okay, between these two the area is 275. Suppose 100 and 125, the area is 260 kilometer square. This is suppose 150 kilometer square. The area enclosed between 140 and 150 is 380 kilometer square. 215 kilometer square, and 165 and 180, it is 120 kilometer square. So area enclosed between the isohyets they are giving. So we can directly find out equivalent uniform depth. How we will find out? So just we have to take the average of these two isohyets, 75 and 90. So 75 plus 90 by 2 multiply by 60. Okay, so just you have to take the average, 75 plus 90 divided by 2 into 60. Same way 275, the average will be 90 plus 100 by 2 plus 260, 100 plus 125 by 2, okay, plus 150, 125 plus 140 by 2 plus 380. 380 will be 140 plus 150 by 2 plus 215, that is 150 plus 165 by 2 plus 120, that is 165 plus 180 divided by 2. Okay, so divided by this whole thing, divided by total area. Total area is the sum of all this. Okay, so total area, to get equivalent uniform depth, we have to divide this total by 60, total area 60 plus 275 plus 260 plus what is there 150 plus 380 plus 215 plus 120. Okay, so just calculate this whole equivalent uniform depth. So basically what we will get the average rainfall. These are the see, isohyettal method is one of the most accurate method among the other two methods. Okay, 75, 90, all these are, and it requires high skill. Okay, so area between these isohyets are given. So it is one type of, we can say that we are taking average only, average of both the isohyets and multiplying with the area. Okay, so here almost you will get answer, equal to 130 mm, 130.04 mm. You will get this answer. You can check it afterwards. Okay, and many times they are giving see, many times they are giving some coefficient of runoff also. Coefficient of runoff, suppose the value of C runoff they are giving as C is equal to 0.4. okay, then we are supposed to multiply this coefficient of runoff with this, then only we will get actual depth of flow. So depth of flow will be your C, coefficient of runoff multiply by equivalent uniform depth, so it will be 0.4 into 130.04. okay, so actual depth of flow you will get around 52.02 mm. 52.02 mm you will get. And finally, if they are asking you the volume, okay, suppose they are asking you the volume of runoff. Okay, suppose they are asking you volume of runoff. If they are asking you volume of runoff, then it is easy, area into depth or depth of flow, which we have just found out, multiply by area of catchment. Okay, so area of catchment, we know depth of flow also, so we can directly find out the volume of runoff. Okay, thank you very much.